Good night, everybody. We're trying to find two values in a least residue system here. And let me just write down what that is for modulo 59. The least residue system is the set of remainders when you divide a number by 59. So that would be 0, 1, 2, ellipsis, all the way up to 58. And again, that's common language in a number theory textbook. It's called the least residue system. Now, a complete residue system would be like 1, 2, all the way up to 59. So any consecutive 59 numbers would be a complete residue system, but this is the least residue system. So we're trying to actually find two unknowns, which seems counterintuitive because we have one equation here, but it's not really an equation, it's a congruence. Okay, so let's move along. Now, again, I've talked about this briefly. The Legendre symbol is something that predicts a solution to quadratics. And there's a lot of math behind it. I don't know much about it, but I do know that 3 is considered to be a perfect square modulo 59 because 59 is congruent to 1 mod 12. Let me write that. 59 is congruent to 1 mod 12. And if you're not familiar with congruence, that just means that 59 minus 1 is a multiple of 12. 59 minus 1 is 48, and that's 4 times 12, okay? So that means this 1 is notation that there will be a solution to this. Now, this looks kind of cumbersome, but it's actually quite useful, and I'm learning it right now. I've known a little bit about it for a long time, but I'm trying to get into it a little bit more. But we know there's a solution, but it's an existence thing. Finding it's another thing. Now, say if it was in the 30s, it would be hard to calculate, but it turned out this Legendre symbol says there is a solution, and we found it to be 11 squared, and that was just going through checking. Now, you know 59 is a big enough modulus where you don't have to try 1, 2, 3, 4, 5 or anything like that. So 11 squared is 121. 121 minus 3 is 118, and that's 2 times 59. So we can write down x equals to 11 right here. We'll just put that. It'll be kind of useful to write it right here, I guess. X equals 11. Now, yeah, I've chosen to do it in a way that perhaps is not conventional. I don't know, but I want to reduce, and I put that. What I mean is reduce it in modulo 59. Get the variables, because see, this is quite a bit of information. We know that 11 squared is always the same thing as 3. This number is 121, but it's the same thing as 3 modulo 59. So you can see that re-expressing this using laws of exponents with a bunch of squared stuff, with x squared happening all over the place, is very, very useful. Very, very useful. And that's all this is more of an exercise in exponents, really. Now notice here that I made it red here, and I made it red everywhere I put it in. And I enjoyed just keeping the x in here to keep it like an equation. You didn't really have to do that, but it kind of makes it explicit that x equals 11 is the solution. You know what I mean? You didn't. The way I did it would have, you could have carried the 11 through here all you wanted. That would be fine. I just kind of like doing it this way to keep it in this slightly more, shall we call it terra firma, okay? Now, if you add up all the constants here, you're going to get 13x, that this is equal, okay? Not congruent, but this is equal. It's both, actually, but it's more specifically, it's equal. This is equal to 13x plus 39. And y'all, this would be like in your algebra class where they say collect like terms. So you have 9x here, 3x here, and then a single copy of x right here. So that adds up to 13. And these other numbers, 27, 9, and 3, sum up to 39, I believe, don't they? 3 and 9 is 12. 12 and 27 is 39, okay? But now, but 13x, x is 11, right? So this ends up being 182. Okay, 182. And y'all notice that this is congruent to 5. And y'all, again, it's modulo 59. It's modulo 59. And how do you know that? Well, you know that because 59 divides. 59 is a divisor. What it is, y'all, it's the remainder when you divide 59 into 182. But another way to put it is like this. 59 divides the difference 182 minus 5. Okay. Now that's easy to check. That's equal to 177, and 3 times 59 is 177, right? So that's why 182 is congruent to 5. So that would be our A as far as the question. The question was find an A and find an X. Well, we've just found that X is equal to, let me just put it up here a little bit above it all so you can see my friend here. Okay, so we get, from our work below, we get X equals to 11. And A is equal to 5. And I don't make my A the way they make their A. I make that A has withstood a lot of criticism over the years. But anyway, that's A is equal to 5. And X is equal to 11 is the answer. And notice that they both fall in this least residue system. You could add any multiple of 59, like 70 would be an answer, along with 74. 70 would be an answer along with 2 times 79 plus 5, whatever that is. Okay, so you can add a multiple of 79, but we did ask for solutions in the least residue system. And y'all, just one last thing. This appears like if this were an equation, you go, wait a minute, you have one equation and 2 unknowns. In the real number world, I guess you would have an infinite number of solutions. But here you have unique solutions in a least residue system. Okay? All right. That is all. Thank you for viewing.